next part of the project, which is to compute the bearing capacity, undrained only, for punch-through failure of the type 2 foundations. So we're only going to do the type 2 foundations, so that means we're going to be doing the case 2 foundations. Now, what we're concerned about is that we put our piles down to a sand or a gravel layer, and this sand or gravel layer may be sort of thin. So in other words, in this particular case, this is case 2.2, the sand layer is only 8 feet thick. So what we're concerned about is that the load from this column is going to cause this group of piles to punch through that sand into this clay. So we're concerned about the strength of that clay and failure in that clay region. We're not really concerned about failure in the sand. It's taking the sand as a block and then causing soil failure in that clay that's below it. The clay is the weaker layer. Now, this is covered, for background information, this is covered in Engineering 431 on YouTube, lectures 21 to 25. So those of you who haven't taken that class, you need to review lectures 21 to 25 in Engineering 431. And okay, so at this point I'm going to assume that you have done the review and you understand what I'm saying next here. So what we're going to evaluate is this equivalent foundation. So in other words, we're assuming that this region of the sand punches out, but this acts as a unit, and the end result is that we have something equivalent to a foundation coming all the way down to the bottom of the sand, to the top of the clay, and it has a width of B equivalent. And the B equivalent is equal to the original B, which is here, the original width, plus the thickness of the sand. And in this case, the thickness of the sand is 8 feet. So we are going to analyze the B equivalent foundation. Not this one. We're going to analyze this because, well, we're saying that the two are equivalent. So now we're going to use the standard bearing capacity equation, which is going to break down to the following. I'm going to simplify it for you. We have our NC star is going to be NC times SC IC DC. We will have N gamma equal to 0, and because it's clay undrained, and NQ is 1, again, because it's clay undrained. And what I want you to use for the NQ star, rather the NC star, I want you to use NC star equals 8. So you don't have to look it up, you don't have to compute it. It accounts for the small clay layer thickness, and all of these. So it's approximate. So the equation becomes that we're going to use to evaluate the bearing capacity is that QU is equal to 8 SU plus Q, where Q is equal to the total stress of the soil at the B equivalent depth. So in other words, Q is the total stress here. So we're going to use this soil in this region to compute the Q. And, okay, so what does that look like for a case? We're going to use this table. So I'm gonna calculate it for case 2-2, where the pile depth is 30, the base granular soil thickness is 8. That is this. Well, let's see. The thickness of the sand layer here. That it goes to the top of that sand layer. So we're talking about the thickness of the sand layer right below the piles. The pile cap width is 11. That's given on this page here. Pile cap width is 11. Again, the pile depth is 30, and we're talking about a point of interest in layer 4 here. So the B equivalent then becomes what? Well, we're going to add the pile cap width to the base granular soil thickness. 11 plus 8 is 19, so that gives me my B equivalent. You can sort of see it in this little tiny drawing here. That B equivalent is the width of our equivalent foundation. So that's 19. The B equivalent depth is what? 38, because we have gone 8 feet down from where we've gone through the sand to the top of the clay. Gives us a 38-foot B equivalent depth. So the point of interest we're going to take as the center of the clay. So the clay layer is between 38 feet and 45 feet rather. And so the center of that between 38 and 45 is 41.5. And that means that we're interested in the sigma prime I at that point of interest. And you can all get this. We take this, we're at 41.5 feet, so we have 8 times 105, 22 times 97, 8 times 128, and 3.5 times 115. If I add up all those circled numbers, I get 41.5. So you should add those numbers up, and they should equal to the depth to the center of our clay layer. And then we have the water table. So we subtract off the pore pressure, 33.5. So because it's at 8 feet, the water table's at 8 feet. And so we're 33.5 below that. So we get a sigma prime I of 2310. Okay, so we're going to look at the case where we have no surcharge, and then we have the case with the surcharge. We're looking at both of them. We want to come up with the sigma prime P. Well, with no surcharge, the OCR is given to us in the soil properties. So we're looking at the soil properties here, and we're looking at layer 4, and we look at the OCR. The OCR is 1.05. So we're going to use that 1.05 to get our sigma prime P, and so we take the 2310 from here, and the 1.05 that we just saw, we get 2426. Of course, that means the OCR is 1.05. So now we want the SU over sigma prime I at that OCR. And how do we get that? Well, again, we go back to our soil properties, and well, it's basically given. There's our layer 4, there's our OCR 1.05. So we can go down into this chart here, and we see this is the curve for layer 4, and at our 1.05 is approximately in here. Takes me to that point. I can read it off like that, or it's actually given here and we have SU over sigma prime I at that OCR is given to be 0.52. In other words, that is the coordinate of this point. So, in other words, on these curves, I've given you one point. I've given you that point for 8, and that's 0.75. So in other words, if we read across there, we're going to get 0.75 for layer 8. For layer 2, we're given, it's normally, layer 2 is normally consolidated, which means it's what, an OCR of 1. So that comes in here at 0.35, which is given there. So in other words, the numbers here are the points given there. We have to read the chart for other OCRs, and we'll see how that works in here. So we have our SU over sigma prime I at our OCR of 0.52. So there's our sigma prime I. So what do? I take the 2310 goes there, the 0.52 goes there, and I get my SU 1201 PSF. So with that SU, then I can take and apply my bearing capacity equation, which we've already been given to be 8 SU plus Q. So there's my 8, there's my SU. So that gives me the first part of this equation. How do I get the Q? Well, the Q is the, as we said previously, Q is the total stress at the B equivalent depth. The B equivalent depth is 38, so I want the total stress there. And that total stress, so these numbers have to add up to 38, so I've got 8 plus 22 is 30, plus 8 is 38, and then I put the unit weights of each of those layers there, 105, 97, 128, so those are the densities of those layers. I get my QU of 13,600 PSF. So to get my factor of safety, FS, I have to, well, I'm going to take the QU times the B equivalent squared, the area. So we're assuming that this is square, has a square footprint, and we know that the B equivalent is 19, so it's 19 squared. Then I have to subtract off the volume of the soil. Now what volume of soil am I talking about? I'm talking about this volume of soil right here, sort of this region. It's three-dimensional. It goes 19 perpendicular to the page here. But that is, what is the volume of that soil? Well, the B equivalent is 19, so it's and it goes 19 perpendicular to paper, so that's 19 squared, and then this vertical distance is 38. So the volume is going to be 19 squared times 38. And so that's the volume. Now, what's the unit weight of the soil? Well, just to simplify this, I took 110. That is sort of an average of the 97, the 128, and the 115. So it's just rough. You can put in the actual numbers if you want to get it all in detail, but you can just take an average of these unit weights here for this value here. And then I'm going to divide it by the column load. Now, which column? I'm taking the center column. Why the center column? Because the center column has the greatest load. And we computed those before on the very first page, where we found that the center column has 1,200,000 pounds on it for the case with the 36 columns here. So for the case with 9 columns, you have to, you're going to come up with a different number here for the case with 9 columns. So, but for 36 columns, the center column load is 1,200,000 pounds. Putting all these numbers in, we get a factor of safety of 2.83. Okay, so done with that one. Now we're going to do the surcharge fill situation. Well, what changes? It's just the second part. What's my sigma prime p with the surcharge fill that we did? Well, we can look oops. We had, well, we figured out, where is it on here? No. There it is. Well, it's layer 4. It's not the same case, but we had our sigma prime p is 6310. It was greater than the previous sigma prime p, so we used the 6310. Well, how did we get the 6310? That was the 2310 plus 4,000, which was the weight of the surcharge. So in this case, for that layer with the surcharge, my sigma prime p is 6310, and therefore we so sigma prime p is 6310. Our OCR then is the 6310 over the 2310, which is 2.73. Now we have to go into, with this OCR of 2.73, to figure out the SU over the sigma prime I at that OCR, we have to go back to our soil properties. And so 2.73, we're on layer 4. 2.73 is in here, approximately. We come over here, we get approximately 0.8. It doesn't have to be exact, but approximately 0.8 for that SU over sigma prime I. So that means that so our SU over sigma prime I at that OCR is 0.8. That means our SU is going to be the 0.8 times, again, the 2310. And that gives us an SU of 1848. I can now put that into my equation. The Q is the same as previously. And we get 18,782. We again plug that in to this equation. It's basically the same type of equation, except that we don't put that in. We put that in, and we end up with a factor of safety of 4.4. Finish that case. I'm going to do one more case for you. That's 2.8. 2.8 is what? Now we have the same case basically, but we have a basement. And how do we handle that basement? Well, this first part is exactly the same, so we end up with this 2310. Now, what changes here? Well, we get, this is all the same, so I'm not going to explain that. But now we have, and the 8SU is still the same. But when we get here, now what do we have for our Q? We're going to make a little bit of a conservative assumption. We're going to say this is basically just nothing here. So that when we get our Q, well, our Q is what? Well, now I have this basement here. So I only have, well, it's a 20-foot basement, and we're not, so I only have 18 feet of soil. 18 feet of soil there. So a little bit conservative, but we're going to just say that it's a big open space. And so these two numbers should add up to 18, which they do. And the 97 is for the silt, and the 128 is for the sand. And so we get our Q, we get our a QU of 11,600, and we plug everything into this situation, this equation here. But now what's my volume of the soil? Well, now it's only 18 feet. So the volume of the soil, we're now talking about this volume right here. It's much smaller. So it's 19 squared times 18. And I still took the gamma of the soil of about 110. Again, it's approximate. So we end up plugging everything in, we get 2.89. And then when we do it with the surcharge fill, we have, again, this is the same. Again, now I take this and it goes down to here. And we end up with 16,780 for the QU. And we plug, this is still the same. I take the 16,780, I plug it in there. And of course, again, the center, I'm still using the center column load, which is 1,200,000 pounds. I end up with a factor of safety of 4.45. So what you need to do is to fill out this table for each case. So you've got to complete 2.1 through 2.12. I've done a couple of them for you. So fill out this table. So you'll have a dozen of these things, a dozen of these pages when all is said and done. And then you fill out this table, which is the summary of the bearing capacity. And in this particular case, we looked at case 2.2 with no surcharge, and with the surcharge, I had a factor of safety of 2.83, 4.4. And for 2.8, I had 2.89 and 4.45. And we're going to use a factor of safety of 2.75 for passing. So all of these numbers are greater than 2.75, so they all pass in this particular case. So